Something extraordinary is unfolding in our solar system. 3I/Atlas, the latest interstellar visitor, is getting bigger as it approaches Mars. Astronomers have measured this object's coma ballooning to 340,000 kilometers across, with a tail now stretching over 6 million kilometers, numbers that shatter every expectation and still accelerating. Comets aren't supposed to swell explosively in deep space, let alone in ways that defy decades of models and expert forecasts. What could be fueling this runaway expansion? Is this just a chemical outburst or the sign of something engineered emerging near Mars's orbit? The truth behind what's happening is about to challenge everything we know about cosmic visitors, and it starts right now. Diameter measurements from ground-based telescopes and Hubble leave little room for doubt. In late June, the coma of 3I/Atlas spanned just over 13,000 kilometers. By early July, that figure had climbed to nearly 19,000 kilometers, expanding at a rate of around 550 kilometers per day. Gran Telescopio Canarias resolved an elliptical envelope over 26,000 kilometers across at its widest. But the most startling leap arrived in August, when NASA's SPHEREX instrument detected a diffuse carbon dioxide-rich cloud extending at least 348,000 kilometers from the nucleus. That's nearly the radius of Jupiter. Hubble's July imaging confirmed the trend, with time-lapse photometry showing a steady, relentless swelling. No sudden outbursts, no dramatic fragmentation, just persistent growth tracked across ultraviolet, visible, and near-infrared bands. The numbers outpace every model for cometary activity at this distance. Each new epoch redraws the curve upward, forcing astronomers to recalibrate expectations in real time. A new feature streaks away from 3I/Atlas. A dust tail, thin but unmistakable, now stretches behind the object. Hubble's July images catch the structure lengthening week by week, tracing a faint arc that hints at recent acceleration. Astronomers at NASA and the European Space Agency note the tail's orientation is not fixed. Infrared observations from NEOWISE on July 12th detect fresh jets activating in more than one direction. These outflows, visible in both optical and near-infrared, suggest that dust and gas are being flung outward by localized eruptions, not just gentle solar heating. The jets pulse, fade, then reappear elsewhere on the nucleus, feeding the tail and giving it a restless, shifting character. For scale, even at its current stage, the tail would easily span the distance between Earth and the Moon several times over. Each new jet adds to a growing structure, its reach and complexity outpacing the predictions of comet models. James Webb Space Telescope analysts are tracking a light curve that refuses to flatten. Since late June, the nucleus of 3I/Atlas has tripled in apparent brightness, outpacing every cometary model. Photometric spikes, first flagged by JWST-NIR-CAM, reveal not just more gas, but a surface that seems to be physically enlarging. Albedo mapping shows the reflective area increasing beyond what steady outgassing can explain. The nucleus, once estimated at a few kilometers across, now radiates as if exposing fresh, highly reflective material. No major outburst, no fragmentation event, just a relentless, stepwise escalation in luminosity. Some analysts propose the core is unfolding, exposing new surfaces to sunlight. Each new data point stretches the definition of what a comet's heart can do, hinting at processes that defy familiar playbooks. Orbital dynamicists now track faint structures near 3I/Atlas, possible companions that linger in close formation, resisting the chaotic drift expected from ordinary comet fragments. Instead of scattering, these bodies move in step, their paths mapped by photometric modeling and high-cadence astrometry. Analysts at the Minor Planet Center report at least several persistent features, each brightening and fading, but never breaking away. The effect is to magnify the comet's effective size, creating a multi-object system that defies classic fragmentation patterns. Mars mission planners have begun running sky simulations for October, factoring in the projected brightness of both 3I/Atlas and its companions. If current trends hold, the ensemble could present a spectacle up to 10 times larger than initial models predicted, filling the Martian sky with a coordinated display that challenges every expectation of interstellar debris behavior. NASA's Small Bodies Assessment Group points to a chemical fingerprint that stands out even among interstellar comets. James Webb Space Telescope spectroscopy reveals a carbon dioxide to water ratio of 8:1, nearly 6 sigma above the trend for solar system comets at similar distances. In this scenario, carbon dioxide ice, not water, drives the expanding coma, releasing gas steadily as 3I/Atlas nears the Sun. Laboratory analogues and formation models suggest the object originated in a carbon dioxide-rich region of its home system, with water ice depleted by cosmic rays or trapped beneath a crust. Layered outgassing, not sudden outbursts, shapes the persistent growth. For now, volatile chemistry offers the strongest natural explanation. Oumuamua arrived first, spinning through the inner solar system with a strange, unexplained acceleration. No visible coma, no tail, just a silent change in speed. Borisov followed, behaving more like a textbook comet, its icy core shedding gas and dust in a chaotic natural spray. Now, 3I/Atlas defies both patterns, growing exponentially and assembling what looks like a coordinated entourage. Avi Loeb from Harvard warns against dismissing artificial possibilities. Public science communicators echo the unease. If this is natural, it's rewriting the rules. If not, the implications stretch far beyond comet science. As of September 2025, 3I/Atlas's coma has reached approximately 340,000 kilometers across, with its dust tail extending beyond 6 million kilometers. Both figures confirmed by Hubble and ground-based observatories. Its nucleus brightness has tripled since early detection, and 5 stable companions now orbit the primary body, an organization not observed in previous interstellar visitors. Despite detailed JWST spectroscopy revealing an unusually high carbon dioxide to water ratio of 8:1, standard comet models cannot fully explain the unprecedented expansion or the persistent, organized companion swarm. Experts from NASA and Harvard agree that 3I/Atlas is rewriting expectations for interstellar objects, yet its true nature remains unresolved. As it approaches Mars, the available data confirm its size and activity are increasing at a rate unmatched by any comet before. Whether this is a product of exotic chemistry or an unknown process, one fact is clear. 3I/Atlas is challenging the boundaries of comet science as it nears the red planet.